Hey there, TouchDesigner developers. Welcome to another TouchDesigner tutorial. In this video, we are going to take a look back at the Spirograph method that I posted recently and look at how we can recreate that same method of movement via chops. I had a subscriber on a previous video ask for a detailed look at the chop network that I had originally created to make the Spirograph technique function, which we ended up not using because the code was a lot more straightforward, but he was interested in seeing the chop network so that we can work with chops to modify those equations and get different unexpected results with them. So we are going to take a deep dive into Chopland right now and see how we can get rid of that Python code altogether and just use chops to get the exact same type of functionality out of this. So let's dig right in. This video is assuming that you have watched and completed the first video in the Spirograph series only. It does not have, or the network that I'm starting with here does not have the separate modes set up that we added in the second video, and we're actually not going to recreate those with chops because then we would need, 4 different gigantic chop networks. We're only going to focus on the first formula that we created, which was generating an epitrochoid, and that is what we're going to do here. You could always take this information and recreate those other modes as well, but just for the sake of time and clarity, we are just going to focus on that initial function with this video. So if you haven't seen that first video already, go ahead and pause now and watch that and build the network for yourself, because we're going to basically assume that you've done all of that groundwork already, and we're going to start with a network that is already built. So assuming that you've done that and you've got a Spirograph that is drawing for you in the background, awesome. We will start by first turning off the display flag at the end here, and then we can actually delete this chop execute. We will, as I said, be replicating that functionality with chops instead. That leaves us with a position constant, which we'll eventually use again, but not for now. And then our constants that we set up and our little speed network. And actually, we are going to use all of these things in a slightly tweaked fashion in order to make our new version of the network. So what I've done this time, so that we don't have to flip constantly back and forth between that website with the functions listed on it or Wikipedia in the second video, I've just taken a screenshot of the formula from Wikipedia, which looks terrible in the background here when displayed, but we can just come over here and zoom in and immediately view our function that we're going to be recreating within TouchDesigner. Our variables are pretty much the same as what we created last time. We're going to do one, well actually we won't even do anything different. We'll use the variables we set up in the previous video and work with those and use them to recreate the functionality that we see here. So as I said, we're going to keep the constant portion of this because basically we're going to get all of our constant values into this final null, and that'll be the starting point of the chop network. The speed section of this network is going to be a little bit different. If you remember from our video, this is where we actually were able to control the drawing speed. We are going to keep a portion of it. However, the constant value that we have here is now going to be a part of this constant network up top that was controlled via sliders. This is something that could have been done in the original video and might have been helpful to have been done in the original video, just so that you have all your controls in one location. But we're going to do it now because I think it makes more sense for the way that this network is going to work. So I'm going to start by dropping down a slider comp and renaming that to speed space slider, and then connecting that to our merge. And now we have a fourth chop channel within this merge, and we can come to our rename here and add a third channel name in here, which we are going to call speed. And now we've got that speed channel within our final output of this constant null. And then we can delete this constant here, but we'll keep the rest of this network because we're going to use it in just a minute. So I'm going to kind of shift this stuff over here because we're going to have a giant sprawling network on the right of this. And what we can do, I think the best way to do this, just so that we are pretty organized and don't have 10,000 cables connecting everything, I'm going to start with a select chop, which I will use to grab the chop information from this constant null. And we're doing this because we're essentially going to be selecting this information twice via the select chop so that we can take these constant values, which are found in both equations, and incorporate them into a chop network above that calculates the X position, and again in the network below, which will calculate the Y position. So if we come into our equation here and we take a look at it for a second, you can see that within the parentheses in the first part of both of these equations, we're adding together the two radius values. And I think that is where we will start with this chop network. So the way that we're going to approach this in chops is we want to select both the radius 1 and the radius 2 values and then use a math chop to add those together. So I'm going to grab a select chop, and then within that we will look for the channels with the name radius 1 and radius 2. Now we've got those two together in a single chop. We'll then take a math chop and add that into our network, and then within the combined channels drop down here, you'll want to hit add, and that will give you the added value of those two different radius values. So great, we've got our first two radius values added together, and now if we look back at our equation, I'm just going to open this viewer up and leave it up here so we can keep looking at it. We need to multiply those values by the cosine of, in this equation, theta. Our previous equation, this was the value of t, and essentially this is the value of speed or time that comes into the equation and controls how fast the output is drawn. And we need to calculate that speed value first of all before we can take the cosine of it and then add it into our equation. After testing this a little bit, I found that it's better to have a kind of universal speed parameter, or speed chop in this case, to drive everything for the X and the Y equations, which of course is how this would work in Python script as well. But I found that if you were to use multiple instances of the speed chop, even if they were all synced up to the exact same values, just that tiny little imperceptible lag in time between the processing of those things caused the output drawing to be slightly distorted, basically. And although it was close to the original, not exactly the same. So what we're going to do is kind of set up a universally referenceable speed parameter via the speed chop, which is going to function exactly like in our original network. And then we're going to use that to drive both the chop network for the X values and for the Y values as well. So we need to do a couple of things here. We already have basically everything set up. We do need to, however, bring in the value of the speed slider, which again is represented within this constant null here. We need to bring that into our speed network below in order to correctly be able to calculate our speed parameter and to be able to switch it on and off with our keyboard in. I'm going to use a select chop, and then I will select that constant null with it by dragging it on top of it, and then we want to grab the speed channel, and then if we connect that to our math, and I'm just going to switch the input order, now it's functioning exactly like it was before, except that we have control over the speed via this slider, which is kind of nice from a user interface perspective. I'm going to take both of these things and kind of shift them to the left a little bit because our network is going to grow pretty significantly in size. And now we have a speed null, which we can use more select chops down the road to reference and grab from. and that will drive all of these different networks. So we've got this branch complete, but we now need to grab that speed value, take the cosine of it, and then multiply those two things together. To do that, we need yet another select chop. And we need to reference the speed null that we set up in the first network in order to grab that speed value. And then we need to calculate the cosine, as we see up here, of that value. And then we can multiply those things together. So what I'm going to do is I'm going to rename this select to speed select so that I know that that's what I'm grabbing. Even though I can see the chop channel name, I just want to be sure that I'm referencing what I'm doing here so that if I look at it in the future, I'm not confused. And then I'm going to grab a function chop in order to take the cosine of that theta, or the speed parameter. Change your function here to cosine. And then we want the angle units in this case to be in radians, because that is how the math.cosine function we originally used in our chop execute Python script. It works with the radian units, and in order to have output that functions at the same speed, you need to make sure that your units are the same. So make sure you set that angle units to radians. Then we need to take those two things and multiply them together. And so we'll just grab a math chop to do that. And then within the math chop, come to combine chops and set that to multiply. And now we're getting a value that is representative of that whole part of that equation. I'm going to add a null at the end here. And I guess we can call this, I don't know, first half EQ null or something like that, just so that I know that that is where I'm calculating that first half of that equation. Now we have to calculate the second half of the equation. And I'm going to start with everything within the parentheses first of all. So there's a couple ways we could approach this. I'm going to calculate the r plus r, radius 1 plus radius 2 value first. Then I'm going to divide it by r, and then I'll multiply it by speed. We have calculated that radius 1 plus radius 2 value here. We don't have a null attached to this, so maybe it's not super clear from a programmatic perspective what we have done here from the name of it. So I might just copy and paste this part of the network that creates that again. And now we have those variables. And then I also need to grab another select chop. And again, we don't have to be selecting from this initial select chop here. We could be just grabbing everything from this constant null, which might be a little bit cleaner now that I'm looking at it again. So I think I'm going to just dump this select chop here and do it all via referencing that one, so we don't have 1,000 layers of selects. So just delete that select one and then create a new select reference by dragging this constant null onto that select chop and then onto the copied version below. And then we need to make even another copy of this. And in this case, we only want to select radius 2 because we need to divide those added values by the second radius. So within that select chop, I'm just going to delete this radius 1 channel name. Now I'm just getting the second one. And if we add an additional math chop, we can connect that radius 2 and then come to combine chops and select divide. And now those values have been divided. And finally, what I want to do is multiply those by the speed output of the speed null. So I'm just going to grab this speed select and copy and paste it, and then I'll place it over here. We can just call it speed select 1 because that's what it's doing. So we need to grab another math chop because we need to multiply this value by our speed value. And we will just grab one now and drop it down, connect both of those things to it, and then come to the combine chops setting and set that to multiply. And now we've got everything within those parentheses. Finally, we need to take the cosine of that value, and then eventually we'll multiply it by our position value. But first, we need to grab that function chop, and we need to take the cosine of that value coming out of that math chop. We need to set this to radians again so that we get the correct units. And then finally, we need to multiply this by our position value in order to get this whole right half of the equation complete. And so I'm going to use another select chop. And for some reason, it really wants to connect to everything. Let's just, oh, it's probably because I originally had one called that. Okay, make sure yours is not connected to anything yet. And I'm going to grab the constant null again, drag it on top of that select, and then I need the position chop channel from there. And now I can take those two things and multiply them together again via the math chop. Same exact setup as before, where we come to combine chops, multiply. And that, if we add a null, is our second half of the equation complete. Now we need to take those two things and subtract the second part from the first part in order to calculate our final x position value. I'm going to kind of shift this back a little bit since we're taking up so much real estate here. I'm going to move this null so that it's horizontally in line with the other one. And then we can take the output of those two things and subtract them, again via the math chop. So if we connect both of those things to this math and then combine chops subtract, now we have our final x position value. Feels good, doesn't it? I'm going to rename these chop channels because I don't know what any of this means really. Because we haven't labeled it yet. And I'm going to call this one x position because that's what we're calculating. And then I will add a final null at the end. And this one will be called x position null. And that's it. We calculated our x position. Way more work than the chop execute. But now that we have this all functioning in chops, you can use any of the other chop functions that we have to modify that and to explore further with a whole slew of different options for modifying those control signals. We're not done yet though. We still have to calculate the y position and then connect all of it up and make sure that it's working. However, thankfully we can copy and paste all this, so most of our groundwork has already been laid. So let's go ahead and copy that entire chop network and paste it and move it below. And then we'll kind of recenter both of these things. Now we have a second set which can be used for calculating the y parameters. And all we have to do really here in order to make this work is change the cosine functions to sine functions. So come within both of the function chops that have been set up already and change the mode to sine SINE, which is the fifth option, not the third option, SIGN. So again, the fifth option, SINE for sine. And we'll do the same thing with the second function chop there. Once both of those are set up, we are now calculating a y position as well, but we wouldn't know it by what the chop channel has been named. So we need to rename that to y position. And then we'll change the name of the final null here to y position null. And that's it. We've calculated both of the position values for our spirograph. And so we still need to connect that into our network to start drawing once again. In this case, we can delete this position constant because we are no longer working with the chop execute, and instead use a merge chop to take these two position nulls and combine them into a single chop, and then we can connect that to our trail. And hopefully, if we've done everything correctly, we should be able to look on our output now. And if I clear it by hitting the 2 key, it should draw exactly the same drawing that we saw earlier. And with that, we have a network that replicates exactly the functionality that we created within code. Obviously, this took a lot more work in order to get running, and it is, not as easy from a functionality standpoint to kind of look at and understand. However, it does enable you to start working with all of the different chop functionality that's built into Touch to modify these channels however you want. And I think that in itself allows for a lot of experimentation and unexpected results. One of the things that I found when I started experimenting with this was I was not using a unified speed control network like our original, which used a single speed chop for everything. I was using multiple speed chops per X and Y positioning chop channel, or chop networks rather, and I found that it started distorting the output of my image. And that's not something I necessarily would have come across had I done this with code, because I wouldn't have really thought to use separate speed chops to control things. But that said, it just allows for you to start tossing in different operators and seeing how they affect the numbers in the output in a way for TouchDesigner users is probably more intuitive and exploratory than maybe dealing with code and importing functions and things like that. So I'd recommend, if you're interested in this technique in the first place and just want to try it out, to do that and start to, learn how you can use chops for recreating these complex mathematical functions. And then from there, just really push it and try tossing in different types of chops that you maybe wouldn't have thought would do anything or work, and see how they affect the output, because there are lots of different things that you can do to modify it. So with that, I guess we'll start to close this video out. As always, like and subscribe. This has been another TouchDesigner tutorial. I hope that you learned something from this video, and make sure that you subscribe to keep up to date with the content that I'm posting. I'm going to be, continuing to add more and more TouchDesigner content to the channel, and I think that you'll find it hopefully just as interesting as the previous videos that I've made here. If you want to keep up with me on a more day-to-day basis, you can follow me on Instagram at Jack Delora, same name as the YouTube channel that you're watching this on now. I will often post just like experiments of stuff that I'm working on, either for YouTube videos or just my own personal interest. So feel free to, follow and just keep up to date with what I'm doing. And as always, if you run into issues as you're building this, feel free to leave a comment and we can try to figure it out. Also, if you have any suggestions for future videos, whether it's extrapolating content from this video or others, or, completely new topics, feel free to leave a comment. And with that, I look forward to seeing you in the next video.